Today we're going to be completing the remainder of this worksheet that was passed out in class. Now keep in mind this worksheet is not one that I have self-created. Usually those will have my last name up here that says Morrissey. So this is one that I pulled off from the web that I actually really liked because of the variation of the questions, and it came with an answer key that I can just quickly flash up. So you'll see the ones that we have already completed from our lecture. So if you need some sort of a deep dive into that lecture, these ones have been completed. Now I'm going to have you pause the video and see what you can try out on your own. And then I'm going to show the answer key to see if you got it right. Then, of course, we are going to be working on the remainder of these first to see if we still need help. So first here we have an exponent where we want to show the power itself. Now, keep in mind what we know about your chain rule, right? We want to derive the outside function first, that is with e, and then we want to derive your inside function, that is your exponent. So I'll do the first few kind of in parts, and then I will show you later on in this video, once we kind of get started, how I would normally do it without having to break it up. But in our case, we could just go slow to start. Is that if we have your most basic function here of e to the x, the derivative of that is itself, always itself. Therefore, if we were to take away your e, whatever is left over is your next function. That is your inside function. So derive what you normally would with this function here. Well, that 1/2 would come down, and then we would subtract 1 from the exponent. So that would be -1/2 here. So now when we put it all together, or if you want, you can say that this is, because it started as a rational, we can go ahead and convert it back. And you'll notice that this 2 is already in the denominator. We have a negative, so that'll drop it down. And then to put it back into the radical form. So all together, right, keep in mind your chain rule. It's the derivative of the outside. So that would be e to the x. Now, x, we said, has that inside function. So that would be your g of x. Oops, one more time, your g of x. So for us, that would be the square root of x. So it's just rewriting itself once and then taking the derivative of the square root of x, which we know to be 1/2 root x. So all together, we have e to the root x over 2 square root of x. Let's do it again with something a little bit more like 40. So you have e here, so that's going to require its own chain rule, but you also have the product rule here. So keep in mind with the product rule, if we still need to break it up, we can. One function we'll just say is x. Deriving x is 1. The other function is e of 4x. Now this is where I might just show you what I would do normally. So we take e, we write that whole thing once more, and then we multiply it by the derivative of your exponent. So your exponent being 4x, it would just be 4. So altogether, this would be 4e to the 4x. So when you put it together with the product rule, keep in mind what the product rule is, which actually I have written down here, is that it's the derivative of the first, that would just be 1e to the 4x, plus the derivative of just the normal and then the second. So x times 4e to the 4x. Now, some teachers might have you stop here, but for me, I have mine simplify a little bit further. So I'm going to highlight what they have in common, which is this e to the 4x. So I'm going to take it out of the mix. And whatever I didn't highlight will come on the inside of your parentheses. So this would be 1 plus 4x, and that would be the simplified form of this derivative. Let's do a few more here. So this one, your E is tucked into the parentheses. So that means in order to derive your T here, we first need to complete the chain rule. So this power rule will come down. So this 3 will come down. So we have 3. And keep in mind how the chain rule goes. This is the outside, leave your inside alone, times the derivative of your inside. So notice that your inside function we haven't touched, we haven't derived yet. So we're going to write this function all over again. And now we can go ahead and subtract 1 from 3. So that makes 2. So that is the derivative of your outside with your inside. Now we get to derive your inside function. So deriving e to the negative t, so if we still need to break it up, right, we first write itself and then write the derivative of t, that would be -1. So that first part of it is e to the negative t times -1, or if I made it a little bit simpler, just do the negative. If we were to do it again here, we could say plus, again, we can say maybe this is just f of x e to the t. We can just derive itself and then chain rule it with just 1. Again, the derivative of t is just 1. So e to the t times 1, or just e to the t. So we have 3 e to the negative t plus e t times negative e to the negative t plus e t. Now, I'm always one that says, okay, if it starts in some certain form, and if there's no like other direction, we can kind of leave it as is. So notice that we have a negative exponent here and they didn't push it down into the denominator. So if it starts as is, we can kind of leave it at the very end. That's how I take a look at it for my students. Oh, and notice that I left off my 2. Don't forget to bring that 2 down. Let's do it once more here. Then this one you might consider breaking up. You can say your f of x is your x value, or in our case, it's a t. So I actually should write f of t here. So if you take away this e, what's left over is your g of t, -3 over t squared. So let's go ahead and derive for a moment. The derivative of e is itself. Now this one, we want to show the power to it. So we raise it up and have it negative, so that when we go to take your derivative of it, your 2 comes down. So -2 times -3 makes a positive 6t, and you subtract 1 to make this a little bit more negative. So this is 6 over t cubed. So when we put it together, and actually what I like to do sometimes is kind of map it out. As if I get rid of this part here, when you go to do that chain rule, right, we start with the derivative of your outside multiplied by the inside of the g of t, and then it moves downwards. So for us, if we just have e to the t, t is really -3 over t squared. So it's itself times the derivative of 6 over t cubed. So altogether, we have 6 e to the -3 over t squared all over t cubed. Now we have the last one here. You might be tempted to say, okay, this is really 1 over this whole thing because that is the derivative of ln. But keep in mind what we might know about your properties of ln is if you see that division sign, one thing that we can do is break it up into parts. So if we have division, we can just go ahead and subtract and make multiple ln's. Right? We have 1 plus e to the x minus, leave some room, 1 minus e to the x here. And we're just going to make a series of ln's. Now we can go ahead and derive these separately. So deriving ln, keep in mind the derivative of ln is 1 over x. So for us, this is 1 over x being that whole inside. And then when you chain rule it, we can derive this part. So what would be the derivative of this? Well, 1 is a constant, so it gets removed, and e to the x derivative is just e to the x. So this is multiplied by e to the x. So that first portion is e to the x over 1 plus e to the x. And no, these e to the x's do not cancel because your denominator is acting as a unit. We can do the same thing, minus 1 over 1 minus e to the x, and go ahead and chain rule it one more time and derive. We have negative e to the x here, or multiplied by negative e to the x. So that double negative here will turn this positive. So I'm going to make that positive, e to the x over 1 minus e to the x. And again, same thing, we cannot cancel these out. So that should be it. Again, if you want to see the remaining of these questions, how we did this one, it is tucked into that lecture from, I want to say that was chapter 4.5.